let's look at sigma notation. There is a certain notation we use for sums. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is the sum as n goes from 1 to 6 of n. And in this case, the sum is 21. It adds up to 21. We call this notation sigma notation because this is the Greek letter sigma. It's a capital sigma. Here's another example. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared is the sum as n goes from 1 to 6. In other words, n takes on the values 1, 2, 3, 4, 5, 6 of n squared. And when you add it up, it ends up being 91. How about 2 cubed plus 3 cubed plus 4 cubed plus blah, 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 plus 120 cubed? This is sum as n goes from 2 to 120 of n cubed. Now the index, in this case n, is arbitrary. We could just as easily have written this as the sum as k goes from 2 to 120 of k cubed. Or we could have used I. It doesn't really matter. Now let's do the reverse. I'll give you the summation notation. You tell me the sum. Find the sum as k goes from 1 to 4 of 2k plus 1. Well, this will be 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1. In other words, it's 3 plus 5 plus 7 plus 9, which is 24. How about the sum as I goes from 3 to 8 of negative 1 to the I times I? Well, that'd be negative 1 cubed times 3 plus negative 1 to the 4th times 4 plus blah, 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 all the way up to negative 1 to the 8th times 8. So it'll be negative 3 plus 4 minus 5 plus 6 minus 7 plus 8, and all of that adds up to 3. Okay, now suppose we have a function f of x. Write f of 1 plus f of 2 plus f of 3 plus dot, 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 plus f of 1,000 using sigma notation. That would be the sum as n goes from 1 to 1,000 of f of n.